Why is it that while liquid hydrogen refueling stations have already been commercialized globally, our country has yet to see even one? How far are we from the commercialization of liquid hydrogen storage and transportation for civilian use? Let's first look at the policy aspect. In the first half of this year, the Ministry of Transport has already released a draft for the technical specifications for the road transport of hydrogen, including liquid hydrogen. Currently, it seems that there are no longer any obstacles at the standard level for liquid hydrogen to be on the road. We just need to wait for the official document to be issued. Let's take another look at the technology and equipment aspect. The domestically produced large-scale hydrogen liquefaction device, which has a capacity of 5 tons per day and is led by the Institute of Physics, Chinese Academy of Sciences with participation from Zhongke Fuhai, has successfully operated. This marks that China has fully mastered the design, development, production, integration, operation, and debugging technologies for large-scale hydrogen liquefaction equipment and has the supply capability for large-scale hydrogen liquefaction equipment. For liquid hydrogen to be on the road, equipment must come first. Recently, I went to the Bay Area for research, specifically to conduct an inspection in Kaiping City. Guangdong Jiancheng Machinery Equipment Kaizhou Ltd. is also one of our important strategic partners. A subsidiary of Zhongke Fuhai specializes in producing storage and transportation equipment, and it has now achieved mass production and delivery of domestic liquid tankers. Now, looking at the cost of liquid hydrogen, we use a daily scale of 10 tons as a benchmark, and the main component of the liquefaction cost is the depreciation of equipment investment. With the operational amortization and the energy consumption for liquefaction, we calculate the average electricity cost at 0.4 yuan per kilowatt hour. Assuming the cost of hydrogen is 15 yuan per kilogram, the comprehensive cost after liquefaction is approximately 30 yuan per kilogram. The storage and transportation phase is where the advantages of liquid hydrogen lie. Currently, high-pressure tube trailers have a single loading capacity of around 300 kilograms. What about the economic radius? For a distance of 200 kilometers, the transportation cost is about 5 yuan per kilogram. The loading capacity of a liquid hydrogen tanker is 10 times that of a high-pressure tube trailer, allowing for an economic radius of 3 tons per trip, which can be extended to 1,000 kilometers with a transportation cost of about 1 yuan per kilogram. Now, looking at the refueling aspect, the refueling cost at liquid hydrogen storage type refueling stations is approximately 8 to 10 yuan per kilogram, calculated based on a distance of 300 kilometers. The comprehensive cost of hydrogen refueling infrastructure is between 41 to 43 yuan per kilogram, which is cost-effective. If a subsidy of 6 to 8 yuan per kilogram of hydrogen is provided, it can be achieved after the subsidy. 35 yuan per kilogram. From an investment perspective, it is necessary to have a certain foresight. The compatibility of liquid hydrogen refueling stations is stronger as they can accommodate both 35 MPa and 70 MPa gaseous hydrogen refueling, and they can also meet the hydrogen demand for future liquid hydrogen passenger and commercial vehicles. In the next issue, we will look at how to break the deadlock in the implementation of liquid hydrogen refueling stations from a market perspective. Follow Zhenyi and let us seize the development opportunities in green energy together.
Goodbye.